Welcome to the FMSP online revision. This session is for AQA M1, topic is kinematics, and we're looking at question 3 from June 2011. So we'll start by just reading through the question. So we've got a pair of cameras recording the time that it takes a car on a motorway to travel a distance of 2,000 metres. A car passes the first camera whilst travelling at 32 metres per second, and the car then continues at this speed for 12.5 seconds and then decelerates uniformly until it passes the second camera. So these two cameras, 2,000 metres apart, okay? And when it passes this second camera, the speed has decreased to 18 metres per second. So, firstly, we're asked to calculate the distance travelled in the first 12.5 seconds, then find the time for which the car is decelerating. We're asked then to sketch a speed time graph for the car on this 2,000 metre stretch, and lastly to find the average speed of the car over the 2,000 metres. So let's just sort of have a look at the beginning of this question. So I've written the question up again there. So in part A we're asked to find the distance travelled in the first 12.5 seconds. So remember that it's travelling at constant speed because it continues at this speed of 32 metres per second for 12.5 seconds. So there's no acceleration. So if you're thinking of the formula S equals ut plus a half at squared, then of course there's no acceleration. So we really just need the fact that the distance is the speed times the time. So we have a speed of 32 and a time of 12.5. So the distance is going to be 400 metres. And then if we look at part B, the time for which the car is decelerating. So just sort of we're travelling at constant speed and then we're decelerating. So we have this constant speed of 32 and then we decelerate until we get to 18 metres, and we want to know the time it takes us to do that. So we're told that we start at 32 metres per second, we decelerate until we get to a speed of 18 metres per second, and we do that over a certain distance. Now think about the fact that the two cameras are 2,000 metres apart. We've travelled for 400 metres at a constant speed, so we've still got another 1,600 metres to go. And what we're being asked to do is to find the time. So we will be drawing a more accurate graph in a minute or two, but we have this sort of a sketch here. So 32 and it travels to 18, decelerates between these 2 points here, and we want to know the time that it takes. So what we're going to do, we've got u, v, s and t. So what we need is to use the formula S equals a half of u plus v times t. So effectively it is just the area of this trapezium. Should recognise it. So if we substitute that in, S is 1,600, u is 32, v is 18, and t is what we're trying to find. So just 32 and 18 is 50. If I multiply both sides by 2, we get 3,200 over here, and then we'll divide by that 50. And that tells us that the time is 64 seconds. So we're 12.5 seconds to take us to here, and now another 64 seconds. So not a very accurate diagram there, but it was just to help us. But in part C, we're asked now to actually draw a sketch, a speed time graph. So we use all that information that we have. So we start with a speed of 32, and we only travel at that speed. So this is speed, the vertical axis, and time here. So we travel this speed just for 12.5 seconds, and then what we're doing is we're decelerating until we get to 18. Now it is only a sketch. You could use a ruler and it would make it a little bit better, but this was 12.5 seconds. Put a 0 in there, and this, if you remember, there was another 64 seconds that we worked out, so if we add that on to the 12.5, we'll get 76.5. So that now is our speed time graph, and it's just important that you have the 32 on, and the 18, the 12.5, and the 76.5. So those are all our labels, and then so that's part C, and then in part D, the last part, what we're asked to do is to find the average speed. So remember, the average speed is the total distance over the total time, and so we have a total distance of 2,000 meters between these two cameras, and we now have worked out that it took 76.5 seconds. So if we work that out, that comes to 26.143, on, but again we'll give our answer to 3 significant figures. So the average speed, and I notice I didn't put in the word speed here, but I think we're all right. Average speed, total distance over total time. So again, if we just have a little look at the marks for this question, going back to the beginning. So there was 1 mark here for working out the 400 meters, and it was just sort of like a 1 mark without any method, just a statement mark. You then got a method mark for using S equals a half U plus V times T here. You got an accuracy and a dependent method mark, another dependent method mark. At this sort of stage, and then an accuracy mark for the correct answer. Now the dependent mark was the use of the constant acceleration to find t. As long as you had the 32 and the 18 in there, then you would have got a method mark there too. So 4 marks for A and B, and then if we look at parts C and D, then when it comes to part C, there were 3 marks for that. So you got a 1 mark for the shape, so the sort of correct shape. You got another B mark, for the correct velocities. And then you also got a mark for the times. So just make sure that you do remember to label your graph. And then in the last bit, you got a method mark for distance divided by time, and an accuracy mark here for 26.1. And it was a follow-through accuracy mark, so if you made a mistake perhaps with your 76.5, then as long as you actually did the correct calculation, you would have been okay. So 9 marks in total for that question. So don't forget that if you want to access more revision videos, then you can do so by going to the Further Maths Support Programme website and following the link to online revision.